Up there, there's an object 1.2 trillion times heavier than our sun, and it's hurtling toward us at a speed of 430,000 kilometers per hour. This object is a galaxy, the Andromeda Galaxy, and its fate is already sealed. We are going to collide with it. And to witness this epic collision, all you have to do is wait a few billion years and then look up at the sky. What you're seeing on the screen right now is a simulation from the surface of a hypothetical planet in our galaxy, showing this cosmic collision that should begin in about 3 to 4.5 billion years. In its distant future, the gradual merging of our Milky Way with Andromeda will turn the sky into a real fireworks display. Because as the gas clouds of the two galaxies intertwine, they will create contracting high-density regions, and this will lead to the formation of hundreds of nebulae, and billions of new stars that will light up the skies of that era with 1,000 fires. We still don't know exactly whether this galactic merger will begin with a head-on, chaotic, and violent collision, or if it will be more gradual at first. Like a dance between two partners, where the protagonists, in languid back-and-forth movements, start by brushing past each other before finally embracing. In any case, all simulations agree that a complete merger is inevitable. Thus, following a choreography spanning several billion years, the two spiral galaxies will eventually break apart and merge, inevitably leaving behind a single unique giant elliptical galaxy, in which the rotational movements of the stars are no longer organized in the plane of a disk, but now follow disordered and chaotic orbits in complex, winding paths around the galactic center. During this cosmic collision, due to the tiny size of the stars compared to the interstellar distances that separate them, the risk of collision will remain minimal, to the point that it is estimated that the probability of two stars coming into contact is lower than that of two rifle bullets, both fired at random by two enemy soldiers, several kilometers apart, colliding in midair. Despite everything, after a long process, the supermassive black holes sitting at the center of each galaxy should dangerously approach each other, start orbiting one another, and eventually merge. And after such an event, maybe it will be time to change the name and call the newly formed giant Milkomeda or Andromeda. In short, galaxies are not unchanging. They are constantly evolving, brushing past each other, colliding, merging, and these interactions are nothing unusual. To be convinced of this, all you have to do is scan the deep sky with our telescopes. Up there, you can observe thousands of mergers involving galaxies of all types and masses. In fact, although space is extraordinarily vast, in the cosmos, nearly 95% of galaxies are grouped in pairs, groups, or clusters. Like here, where you can see no fewer than 75 galaxies gravitationally bound to each other, and in a phase where, in the relatively near future, they will eventually merge to form just one. And when you try to figure out exactly what these upcoming radical morphological transformations will result in, things can get messy very quickly. Because whether they're dwarf or giant galaxies, the size and mass of the main players can vary by a factor of 1 to 1,000. So, depending on their mass, their respective speeds, and their trajectories, these interactions can give rise to a whole range of different shapes. Some of these mergers that we can observe are just beginning, in progress, or already completed. They can be gentle or extremely violent, and after several billion years of intense gravitational clashes, they can leave behind galaxies with a chaotic, shattered appearance. Sometimes the galactic arms are barely deformed, slightly disrupted, and other times they are severely distorted. We find them torn away, forming tentacle-like bridges of matter connecting the two combatants, even though they barely grazed each other in space. Like here, where the Cocoon Galaxy, which distorts and stretches its neighbor, to which it is connected by a bridge of gas about 24,000 light-years long, has ended up triggering the formation of brilliant clusters of millions of blue stars. In the vast majority of cases, as they intertwine, the clouds of gas that mix together condense before collapsing, giving rise in the process to bursts of new stars, as can be seen with this pair of galaxies known as the antennae. This collision, which began about 500 million years ago, has disrupted and compressed the interstellar medium and has triggered bursts of star formation as a result. These intense starbursts can be responsible for the formation of tens of millions of young massive stars, visible here in the bluish regions. Exceptionally, they can even cause spectacular ejections of matter crossing the entire galactic disk. These immense veins of dust and gas are thought to have formed as a result of gravitational disturbances caused by the passage of another galaxy nearby, several tens of millions of years ago. And if you want to imagine the amount of matter this galaxy is able to turn into stars, just know that, on average, 2 to 10 times more stars light up here each year than in our own galaxy. Even though M82, that's its nickname, is 5 times less massive than the Milky Way. At other times, although it's a close call, the protagonists of these games of influence can undergo significant distortions due to tidal forces. Here, this spiral galaxy, 4 times larger than ours in size, has seen its arms stretch out under the gravitational pull from its small neighboring galaxy. There, the Tadpole Galaxy owes its astonishing shape to the fact that a few billion years ago it was crossed by a smaller and extremely fast galaxy, to the point of stretching one of its arms, giving it that spectacular tail shape, about 280,000 light-years long. Just like the animal it is named after, this galaxy will eventually lose its tail because the clusters, rich in hundreds of thousands of stars that we can see here, will end up gathering together to form small satellite galaxies. Exceptionally, when they move at extremely high speeds, reaching or even exceeding 4 million kilometers per hour, or when they interpenetrate through the core, these collisions can give rise to astonishing shapes, to the point that sometimes the participants come out unrecognizable. Here, you can see the final stage of a cosmic catastrophe that caused 2 small galaxies to become entangled, eventually merging completely to form a single galaxy with 2 outer nuclei. And in the wake of their movements, a tail stretches out, made up of gas, dust, and newly formed stars. As for this galaxy, known as a ring galaxy, it is believed that it once had a shape identical to ours, before it was struck by a head-on collision directly at the cores. Thus, this immense structure surrounding the center would have formed after a smaller galaxy by passing through the galactic core, triggered the propagation of a wave, a concentric shock wave that disturbs and sweeps away the gas and interstellar dust in its path, eventually causing the formation of a ring on the outskirts, richly endowed with massive young and extremely bright stars. It is believed that in the future, all these ring galaxies should see the relatively empty areas near their core gradually filled by stars from the outer edge. In short, whether for the spectacle or for the puzzles they pose, the parameters of mass, proper velocity, and angle of approach make each merger a unique event. And even though, inevitably, these mergers initially trigger bursts of new star formation, they also strangely often result in the gas clouds of the galaxies involved in these cosmic crashes being depleted. Thus, in the case of complete mergers, a few billion years after the collision begins, there is often not enough gas left in the resulting galaxy to stimulate the formation of new stars. And that's why, paradoxically, in giant elliptical galaxies, the final product of major mergers, the formation of new young stars is extremely rare. As these merger events follow one another, they can even give rise, at the heart of galaxy clusters, to giant elliptical galaxies of enormous size, which by swallowing up everything that passes nearby and through repeated mergers, have become the central point of clusters. Here, 2 giant ellipticals are colliding, and in this clash of titans, the galactic center of one of them, as if torn apart and drawn in by the gravitational intensity of its massive neighbor, it has been stripped of part of its outer layers, made up of interstellar dust and, exceptionally, stars, torn away and ejected from the battlefield. Sometimes, when interactions occur between 2 galaxies of extremely different size and mass, the balance of forces is somehow not maintained. And we can witness phenomena known as galactic cannibalism, during which the more massive galaxy remains relatively unchanged, while the smaller one ends up disappearing completely. Swallowed, assimilated. From then on, reconstructing the crime requires a sharp eye and staying on the lookout for clues. Here, it is assumed that this strange spiral galaxy has surrounded itself with a shell of gas containing millions of stars, while also producing a jet of matter. After having torn apart by the power of its tidal effects, a small dwarf satellite galaxy, which has now disappeared. There, these large loops were most likely formed as a result of the collision with another dwarf galaxy several billion years ago. Sometimes, the traces and evidence of these past phases of cannibalism can be found in the amount of stars and gas that galaxies contain. Here, this blazing spiral is highly disrupted, with new stars that all would have formed about 300 million years ago, after this galaxy swallowed a smaller one. As for the obvious absence of clouds, gas, and interstellar dust in the disk of this one, it also points us toward a turbulent history shaped by repeated collisions, which have left this galaxy drained and anemic, tired and stripped of its future potential. Because these gas clouds have become too thin and now form very few new stars. And if you still haven't grown tired of the abundant variety of shapes and appearances of these splendid distant collisions, and the idea that one day our own galaxy will collide with Andromeda excites you, yes, then I've saved a chilling twist for you at the end. Because if we set aside the fact that at the beginning of this collision, our sun will most likely have already gone out long ago, well, it's possible that some stars, including the remnant of ours and its entourage of planetary bodies, may see their galactic orbit sufficiently disturbed to end up simply being ejected from the Milky Way, now deformed. Well, if it reassures you, know that it might not even be necessary to wait that long. Because according to the results of a study involving 8 simulation models of the merger between our Milky Way and its 2 largest satellite galaxies, the 2 Magellanic Clouds, there would be a 68% chance that we would merge with them. And that in just 2.4 billion years. And in that case, due to the gravitational disturbances caused, there would be a very small probability that the solar system, disrupted by the arrival of this new matter, could also be ejected. If you think nothing's more absurd than the universe, follow me on Instagram.